Hello everyone, welcome back to the machine learning session. In the previous class, we have seen how you are going to create your own data set using Python libraries, using pandas and NumPy. Let me quickly take you through the data set which we created. So we created the data set in which we have temperature, pressure, vibration, usage hour, maintenance and failure. सो बेसिकली व्हाट वी आर क्रिएटिंग, मैं आपको सिंपल लैंग्वेज में समझाती हूँ। हम एक इक्विपमेंट की टेस्टिंग के लिए ये डेटा सेट हमने क्रिएट किया है। जब भी हम इंडस्ट्री में से किसी डेटा सेट को या फिर हम इंडस्ट्री में से किसी इक्विपमेंट को बाय करते हैं, वो इक्विपमेंट एक टेस्टिंग के थ्रू आता है, जिसमें उसकी टेस्टिंग होती है उसके टेम्परेचर पे, प्रेशर पे, वाइब्रेशन पे, यूसेज ऑफ आर पे, उसकी मेंटेनेंस कितनी हो सकती है, ड्यू है या नहीं है, और वो कितने टाइम के बाद फेलियर हो जाएगा। यही सब सारी चीजें होने के बाद जब टेस्ट होता है उसका, तो उसमें पता चलता है कि ये टेस्ट पास है या फेलियर है। तो उसके लिए हम एक मशीन लर्निंग मॉडल क्रिएट कर रहे हैं जो कि हमें पता लगाएगा वेदर दिस इक्विपमेंट इज पास्ड और फेल। लेट्स क्विकली डू दैट. You all are going to open your Google Colab and we are going to get started with it. So let's quickly open Google Colab. All right. I'm going to open my Google Colab. So let me quickly share that with you. Here is the Google Colab. So first of all, I'm going to go over here and I'm going to open a new file. I'm going to close it. Google Colab. You can open like this also. If you have already signed in, you are not required to sign in again. So this is how it is going to open in front of you. You are first of all going to connect the data. So you are going to open this folder and you are going to click onto this particular option. Take this and click on open. It is going to show this kind of message in front of you. But don't worry, if you have uploaded it, you need not to worry. Now, the next step which you are going to do, you are going to import the step number 1, which we will be following. That is, I'm going to write the steps along. Import libraries and all the libraries, which is import pandas as et, import numpy as np, then import matplotlib.py plot as plt. Yeah. Now import cborn as sns. Next, import, or you can say from sklearn dot model selection, import train test. I hope I need not to explain all these steps because we have already covered all these steps before, right? Now, next part is from sklearn dot preprocessing import standard scalar. All right, so that is what we will be doing. Over here, we are going to change the regression model. We will be taking not linear regression, sklearn dot ensemble import random forest classifier. So this is what we all are going to take. I'm going to explain why you will be taking it. We will be taking matrices, import, score, accuracy, classification report, and confusion metrics. So once you are done with that, then you are going to reach to step number 2. Step number 2 is going to be load data set. And that is, you are going to create a data frame is equals to pd dot read csv, and we are going to put r, and inside this we are going to put the path. Done. Once you have done that, now you will be reaching to the next step, which is going to be step 3, and step 3 is explore data. Print, this is not really very important, but if you feel like, you can do that. Dot head. Now print df dot describe. Describe is basically a library which, or you can say a method which is being called by you. Now, this is an optional step if you would like to visualize it, but we wanted to visualize because we were not able to see any connection in it. All right, so let's quickly do that. So I'm going to put visualization of it. Step 4, visualization, and we are going to put SNS dot count plot. This time we are putting count plot. Data is equals to df x is equals to failure. So this is what we wanted to count. Now we are going to put plt dot title, and title is going to be failure class distribution, right? So plt dot show, our favorite task. Now, okay, everyone, let's quickly click on this play and see how the visualization looks like. So when you are going to see failure case distribution, so over here you can see there is no failure, but over here there is one failure, right? Failure class distribution, this is what it shows. And over here you can see how the title and each and everything is mentioned as per what we asked. So now we can see that 500 rows out of this, and these are columns. So out of these, only one case is as such, which is failure. So there are chances, but now we needed to see in what case is that. So what we are going to do, now we are going to split the data. First of all, we are going to define X and Y, right? And then we are going to split it in test and train. So let's quickly do that. Okay, so we are going to put X is equals to df dot drop. And what we wanted to drop, we wanted to drop failure. And that is on axis 1, right? Now, once we have done that, now we are going to define Y is equals to, that is df fail. Now you needed to make sure that this F is going to be capital. Otherwise, it is going to show an error. All right. So this is what you needed to make sure. These are all features and this is going to be your target. So basically X is going to be your input and Y is going to be your output. Now we are going to reach to our next step, step 5, which is train, test, split. That is what we are going to do. And for that, X, train, yeah. So this is what you will be keeping. It has already taken. You can just copy and paste the same line everywhere in all the code and machine learning which you are going to create. So this is what you will be doing for test train. Now what we are going to do, we are going to reach to our step number 6. 6, that is going to be feature scaling. And you are going to call upon scalar is equals to standard scalar. So you are going to call upon this method over here. Once you have done that, X train scaled, and what is going to be that? Scalar dot fit transform X train. So the same way which we have done in the previous class, you are going to do that for test also. Scaled is equals to scalar dot transform X test. Now this part is done. We have featured it. Now we are going to reach to step number 7, which is train model. Now how we are going to do that? Model dot, sorry, first of all we are going to define it. Random forest classifier n estimators is equals to 100. Random state is equals to 42. So that is what you are going to do, and you are going to do model fit again for X train dot scaled and Y train. Once you are done with that, you are going to move to step number 8. So that is predict. Now over here, we are going to run our prediction. Now what that prediction is going to be all about. So let's quickly do that. Y predict is equals to model dot weight. Model dot predict, and you are going to keep X test scaled. All right. Now once you have done that, you are going to move to the evaluation segment. Now, for the evaluation segment, we are going to complete that part in the next class. So till now, first of all, let me quickly explain why we have taken this particular random forest. But before that, would like to explain each and every part of the code in front of you. First of all, what we have done, we have taken pandas, numpy. So basically pandas is for data manipulation. We have taken NumPy also for the data manipulation. We have taken Matplotlib, PyPlot, and Seaborn is basically for the visualization. Scikit-learn we have taken to split the data set into training and testing set. We have taken scikit-learn pre-processing for feature scaling. We have taken scikit-learn ensemble, that is to contain random forest model from it. And obviously scikit-learn matrices, which is the last part for evaluating the model performance. Now I am going to simply explain what exactly and why we are going to use the random forest for this particular model. Basically, predicting equipment failure involves nonlinearity relationship between features like high pressure, high vibrations, right? And there are possibly unbalanced classes like fewer failures than normal operations. There could be noisy data like random variations in sensor readings because we have not created the data and this is not industry data. It is being created randomly because while you were creating it, everywhere you have written random or rand int, right? So this is basically for that, right? Now, using this random forest, it handles all these very well. Why? Because it reduces overfitting, which is common with single decision trees, right? It handles both numerical and categorical features. It is a robust for the meaning, or you can say missing values and outliers. It provides feature importance which is useful for interpretations. So this is what makes it a robust forest for this particular model. This model is going to work when this particular model, then you are going to get accuracy which is 100% maybe sometimes because we have taken a superficial data created using Python, right? So this is the significance of this particular model. With this model, when you are going to create up to that particular level, you will be able to get greater output or greater accuracy, right? Basically, a random forest classifier is a meta estimator. It fits a number of decision, or you can say number of decision trees classifiers on various subsamples of the data set and uses it averaging to improve the predictivity as well as the accuracy and control overfitting. Trees in the forest use, so basically previously we have used trees. In trees there are branches, you understand, in a manner अगर हम सिर्फ एक सिंगल ट्री पे वर्क करते हैं तो उसमें डिफरेंट ब्रांचेस हैं. ट्री एक पार्ट होता है फॉरेस्ट का. यहाँ पे हम एक एंटायर फॉरेस्ट को यूज कर रहे हैं जहां पे हमारे पास डिफरेंट ब्रांचेस हैं. सो आप ये सोच के देखिए कि हर नोड पे अगर एक्यूरेसी हम फिट करेंगे, प्रेडिक्ट करेंगे, तो उसकी एक्यूरेसी ज्यादा होगी. डिसीजन ट्री पे हम सिंगल ब्रांच और नोड की बात करते थे, यहाँ पे हम ट्रीज को, मल्टीपल ट्रीज को इन्वॉल्व कर रहे हैं. दैट्स व्हाई इट इज कॉल्ड एज रैंडम फॉरेस्ट क्लासिफायर and it holds much more value than a numerous you can say normal classifier. So that also is a part of scikit-learn. Here we have not used tensorflow. यहाँ पे हमने tensorflow को use नहीं किया है. यहाँ पे हमने simple scikit-learn की library और you can say scikit-learn की ensemble को use किया है, which is random forest classifier. और यहाँ पे इसके यूज करने का एक ही मात्र हमारे पास वजह थी, दैट वाज टू कंट्रोल ओवरफिटिंग. क्योंकि जो डेटा हमने लिया है वो एक सुपरफिशियस डेटा है जिसमें हमें नहीं पता कि हमने वैल्यूज क्या रखी है. उसमें नल वैल्यूज भी हो सकती हैं, उसमें मिसिंग वैल्यूज भी हो सकती हैं. उन सारी चीजों को केटर करते हुए रैंडम फॉरेस्ट क्लासिफायर हमें बेटर प्रेडिक्शंस देता है, as well as it creates the accuracy level or it enhances the accuracy level. That accuracy is going to provide much more grace to the model which we are creating, because this model is completely based on scikit-learn, right? That's why यहाँ पे classification report and confusion जो metrics create होगा और जो आपके पास एक्यूरेसी स्कोर आएगा दैट इज कंप्लीटली बेस्ड ऑन द क्लासिफायर विच वी आर यूजिंग. आई होप नाउ यू हैव गॉट द क्लैरिटी of why we have used random classifier, random forest classifier. I am trying that in each model which we are creating, उसमें हर जगह पे मैं एक different module को, different classifier को आपके साथ, आपके सामने introduce कर सकूं. Because जितने ज़्यादा आप classifier को use करोगे, आप देखोगे और जानोगे कि वो कैसे dependent होता है एक data set के ऊपर, आई थिंक आपको उससे ज्यादा समझ में आएगा, आप उसको ज्यादा से ज्यादा यूज करोगे. So that is the major significance why we are using all these. With that, now हम नेक्स्ट क्लास में क्या करेंगे उससे पहले मैं आपको जस्ट एक ओवरव्यू दे देती हूँ कि हमने अभी तक इस सेशन में क्या किया है. सबसे पहले हमने डेटा को विजुअलाइज किया कि हम किस डेटा के ऊपर वर्क कर रहे हैं, जो हमने डेटा सेट पाइथन, नमपाई और पांडास की हेल्प से क्रिएट किया था, विच वॉज ऑल अबाउट इक्विपमेंट फेलियर. कि एक इक्विपमेंट फेलियर किस तरीके से हो सकता है. जब भी हम किसी इक्विपमेंट को इंडस्ट्री से पास करते हैं वो मल्टीपल टेस्ट के थ्रू आता है, जिसमें होता है टेम्परेचर, प्रेशर, एज वेल एज उसको कितना हीट दिया गया है, उसका कितना यूसेज है, उसको कितना प्रेशराइज किया गया है. सो उसका एक सेट होता है जिसपे डिपेंडेंट होता है कि वो फेलियर हो रहा है या नहीं. उन सारे फिनोमिनास को और फीचर्स को कंसिडर करते हुए हमने 300 रोज और 5 कॉलम्स का एक डेटा सेट क्रिएट किया. उस डेटा सेट को विजुअलाइज करने के बाद वी हैव केम टू अ कंक्लूजन दैट दैट डेटा सेट हैज सर्टेन डिपेंडेंसी. उस डिपेंडेंसीज के बेसिस के हिसाब से वी हैव क्रिएटेड दिस पर्टिकुलर मॉडल. इस मॉडल के अंदर आज हमने क्या किया है, हमने लाइब्रेरीज को इंपोर्ट किया है. वी हैव लोड द डेटा सेट, और डेटा सेट को लोड करने के लिए जो डेटा सेट हमारा यहाँ पे था उसको पहले हमने डाउनलोड किया. आज उस डेटा सेट को हम यहाँ पे लोड कर रहे हैं. हमने डेटा सेट को एक्सप्लोर किया है. एसएनएस सीबोर्न लाइब्रेरी की हेल्प से हमने देखा है कि उसमें कोई डिपेंडेंसी है या नहीं है. हम क्लियरली देख पा रहे थे कि एक काउंट प्लॉट के हिसाब से, काउंट प्लॉट का मतलब होता है कि वो नंबर काउंट करता है कि कितने नंबर्स हमारे पास हैं और कितने काउंट हमारे पास आ रहे हैं उसके. इट एक्चुअली काउंट्स द नंबर, बेसिकली काउंटिंग करता है, राइट. हमने फिर देखा है हम कि उसको हम टेस्ट और ट्रेन में कैसे स्प्लिट कर सकते हैं. क्लासिफायर जो हमने आज यहाँ पे यूज किया है वो रैंडम फॉरेस्ट क्लासिफायर के, जिसका एक्सप्लेनेशन मैं आपको बहुत अच्छे तरीके से दे चुकी हूँ. इन सारी चीजों को कंसिडर करने के बाद what we have done, we have now reached to the evaluation part. evaluation हम नेक्स्ट क्लास में करेंगे जिसमें हम MEE, हम क्लासिफिकेशन रिपोर्ट क्रिएट करेंगे, कंफ्यूजन मैट्रिक्स क्रिएट करेंगे और एक्यूरेसी स्कोर को हम देखेंगे और जानेंगे कि एक्यूरेसी स्कोर हम किस तरीके से क्रिएट करेंगे. Till then, this was all about today's session, everyone. Thank you so much for joining us in the next class. Stay tuned and keep learning. Thank you.